Hello students, welcome to the physics class. Today we are going to start a very important chapter of physics of class 10, that is known as light, reflection and refraction. This chapter is there in your higher classes also. So whenever you are studying physics, light is one of the important part of the physics you will be studying every time. So the whole concept or the basic concept of light will be learning in class 10. Please concentrate and enjoy the chapter. So in this chapter we are going to study about reflection, laws of reflection, mirrors, spherical mirrors, refraction, laws of refraction, lenses and types of lenses. Okay. So all those things will be there. So let us start with enthusiasm. So in the beginning, for the introduction part, I just want to tell you that what is light according to you? Light is a form of energy which gives us the sensation of sight. Means with the help of light we can see things around us, right? So what will happen? How can we see object? Like if you can see me, the color of my t-shirt is orange. If you see a tree, the color of the tree is green. How? Whenever light falls in an object, the reflected light come to our eyes, and that reflected light is understood by us that yes, this is a green color or this is an orange color. So whenever you see things, that means light getting reflected back from that particular object and made us the vision. That's how we can feel the light. Now there are three types of medium through which light can pass or cannot pass. As for example, these are the objects which transmit almost all the light falling on them. So whenever light falls on them, the light rays pass through them. Okay. Example I can say glass or glass slab. Whenever light falls on them, light completely pass through those glasses. They do not form any shadows, as because the light passes through them. So there are another kind of medium that is known as translucent. Whenever light falls on them, light passes partially through them. Not all the rays will pass through the other side, some of them will be blocked as well. So this type of object do not form complete shadow, they form partial shadow. Okay. So the name or example I can say tissue paper. Okay. So tissue paper is an example where light passes partially through those objects. Finally, opaque object. Opaque objects are those objects where whenever light falls on those objects, light will not be able to pass through the other side. Means the whole light will be blocked. As for example, wood, and you will see a complete shadow. Fine? Okay. In this chapter, we will be discussing about the geometry of light. For that, you need to know that light travels in a straight line, and these are called as rays. Okay. Rays always travels in a straight line. When two or three rays or more than that combine together, they form beam of light. Okay. So these are the basic things of or the introduction part of the chapter. Now let us start the chapter with enthusiasm, starting from reflection of light. What is reflection of light? The bouncing back of rays from the object in the same medium is known as reflection of light. Light rays coming and striking the surface and getting bounced back in the same medium. This is the medium, suppose this is air. So they get reflected. This is known as reflection of light. It can be seen in the mirror, it can be seen in water, it can be seen through any plane surfaces, objects. Okay. There are many reflecting surfaces. So to understand reflection of light, we need to know what is laws of reflection. Okay. Now if you can see on the screen, whenever an incident ray strikes any plane surface, suppose let us consider that is to be mirror. Whenever it strikes the mirror, a normal is drawn first on the plane of on the surface of the mirror, that is on the horizontal surface, which is normal means it should be perpendicular to that surface, to the reflecting surface. Now the reflected ray bounces back in the same medium. Okay. Now the first law says that the incident ray, the ray which is coming from an object, that is known as incident ray. The reflected ray the ray which is getting reflected back, and the normal which is perpendicular to the reflecting surface are on the same plane. Plane means it can be a xy plane, yz plane or exact plane. So, see, plane does not mean that let me make you understand what this plane means. It is like this surface. If you look at me, if I am in this plane x y plane, now this is another plane. Okay. Now, this can be another plane. So, plane is formed by two dimension. So, in this one, in your copy or in your book or on the screen which you see, that is two dimensional, right. So, two dimensional plane is x y plane, okay. Like this is the plane, understood, fine. Second law is the angle of incidence is equal to the angle of reflection. Angle I is equal to angle R. In any reflecting surface, this two angle has to be equal. Suppose angle I is equals to 20 degree. Therefore, angle of reflection also has to be 20 degree. So, this is all about laws of reflection. Okay. Now, there is one question I need to ask you. If the incident ray is made to fall normally on the surface, means incident ray is coming in such a way that it is coming normally like this. Normally means perpendicular to that reflecting surface. What will be the angle of incidence and angle of reflection? Yeah, if it is falling normally, angle of incidence will be 0, right, because it is along the normal and it will reflect back in the same direction, right or not, making angle 0 degree. Angle of incidence is equal to the angle of reflection as we know. Therefore, angle of incidence and angle of refraction will be 0 degree whenever light falls or the incident ray falls normally on the reflecting surface. Now, let us start the different types of reflecting surfaces. One can be a plane mirror, then you will find spherical mirror called as concave and convex. I will explain all this, do not worry. Then laws of reflection is also valid for all reflecting surfaces. There are two types of images formed. Okay. Now, this is a very important part of the chapter. There are two types of images formed, like the incident ray when it is getting reflected, the reflected ray at, if you keep on one screen on above, it will form an image. The incident ray coming, striking the plane of the surface and going to a screen, then it will form image, right. So, based on that there are two types of image formed. Okay. Now, if you are looking in a plane mirror, you also see your image on the plane mirror, right. So, two types of images are real image and virtual image. Now, what is real image? It is an inverted image, like object is suppose AB, the inverted image will form as BA. Virtual image is an erect image. If the object is AB, the image will also be AB, means the height, I am talking about the height. Real image can be nicely obtained on the screen, means the image will form on the screen, and the virtual image, the image will not form on the screen, then where it will go? Let me tell you. In real image, it is formed by intersection of two rays. When the two rays intersect, then only image is formed. In case of virtual image, it is formed by intersection of apparent rays. Most of the ray in the virtual case will be a divergent ray, means ray will go in this way. Okay. So, you have to take an apparent ray to intersect them. So, we will do some ray diagrams for your better understanding about real image and virtual image. You can obtain the image also, you can draw the ray diagram, do not worry, we will give you the formulas. We will do all this thing in the what? Image formation of in reflection as well as refraction. Now, image formed by a plane mirror. Now, what is that? Now, if you see a plane mirror in front of you, you see your image, right. So, what are the properties of the image formed by a plane mirror? Plane mirror always form virtual and erect image. Like if you are standing, suppose this is A and this is B, the image will also form in such a way on the plane of the mirror, that is plane mirror, A, B only, right. The image formed in the plane mirror is laterally inverted, means your right side will appear to be left on the mirror and your left side will appear to be right on the mirror, that is known as laterally inverted, right. The size of the image is equal to the size of the object. If the object height is 5 centimeter, the height will also for the image is 5 centimeter, right, and the object distance is equal to the image distance from the plane of the mirror. From the plane of the mirror, suppose the object is kept at 10 centimeter away, the image will form in such a way that it is also 10 centimeter away from the plane of the mirror. Now, what are the uses of plane mirror? Plane mirror can be used for a looking glass. Plane mirror are used in solar cookers also. Plane mirror are used in making kaleidoscope, etc. So, these are the uses of plane mirror. So, I hope the reflection part is clear with you, especially the laws of reflection. One more time let me tell you, you have seen it. Okay. The angle of incidence is equal to the angle of reflection, the incident ray, the reflected ray and the normal all lie in the same plane. You have to use this concept and start doing another type of mirror which we will be doing now in the next part, that is spherical mirror. So, that is all from this part. Students, in this part we are going to discuss about spherical mirrors. Okay, what are spherical mirrors? Spherical mirrors are those reflecting surfaces whose surfaces are either curved inward or outward. Okay. It is a sphere actually, or the sphere is cut into pieces. Okay. Now, based on this one, there are two types of spherical surfaces. One is called as concave, that is the curved inward part will be the reflecting surface, and convex, the outward part will be the reflecting surface. Okay. Now, to understand inward and outward, if I have a sphere, and then I cut the sphere into two parts. Okay. So, inside part will be my reflecting surface for concave and outside part will be my reflecting surface for convex. You can take a better understanding using a spoon. If you look at the spoon, the inward portion is your concave and the outward portion is your convex. So, in this part we will be seeing about image formation by the spherical mirrors. Now, before going for the image formation, let us understand the different parts of the spherical mirror. Pole. Pole is the geometrical center of a convex or concave mirror, that is known as spherical mirror. Number 1. Now that we will know the center of curvature. Center of curvature, it is the center of sphere of which the mirror is a part. Okay. Center of curvature lies in front of a concave mirror, and in the case of convex mirror, it lies at the back side. Now, radius of curvature, it is the distance from the pole of the mirror to the center of the sphere, that is till the center of curvature. Okay. That is known as radius of curvature. And principal axis, it is the imaginary line passing through the pole and the center of curvature. Now, there is a point called principal focus. This point is in between center of curvature and the pole of the mirror. If the ray strikes parallel to the principal axis, they get converges towards the focus. Okay. Now, the length of the focus from the pole of the mirror also called as focal length, okay, from the pole till focus. And aperture of the mirror, it is the diameter of the reflecting surface of the mirror, it gives the curvature of the mirror. Okay. With the help of the aperture, you will know how much will be the curvature of the mirror. Why don't you do one thing, my dear students? You take a spoon and place it in front of your face. Okay. First, you place the curved inward part, that is the concave part, and move it back and forth and see what will be the image formation. Will it be clear, or how about the size? Is it decreasing, increasing? Fine. And you again change it, see the convex part, again move the mirror back and forth and see and note down the observation. This is for you. Now, let me give you another work. Take a plain sheet of paper and take concave or convex mirror. First, you take concave mirror and allow the sunlight to falls on it, that is the sun rays. As soon as the sun rays falls, try to get the reflected ray on that page, that is the white sheet which you have taken, plain sheet, try to get a bright point on the page and then move the mirror, or you hold the mirror at that position only wherever you are getting the bright image. Now, what can you observe? Do the observation. Now, take again another mirror, that is your convex mirror, do the same thing, try to obtain the bright spot on the screen with the help of sun rays, okay, and then find out the observation and note what are the observation you got. Now, what is the relation between the radius of curvature and focal length? As you have noticed that the focus lies in between center of curvature and pole of the mirror, therefore, radius of curvature is equal to twice of focal length. So, this is an important relation, please note it. So, in this part we have discussed about convex mirror and concave mirror, and we will have also seen the different parts of the mirror, taking it from pole till principal axis and then focus, radius of curvature. Please give it a good reading, it will help you to understand the next topic, that is your image formation by a concave mirror, which we will be doing in the next part. Now, we will see in this part image formed by a spherical mirror. One by one we will see first for concave and then we will go for convex. So, at first, how can you form the image? When two rays intersect, from that point only we can make the image. There are few important rule, let me tell you, or the important part while making the ray diagrams, that is your image formation. Remember that in case of spherical mirror, the normal always passes through the center of curvature. The normal, in case of laws of reflection you have studied, right, whenever an incident ray strikes, you need to draw the normal. So, out here in spherical mirror, all the normal will pass through the center of curvature, means if a ray comes through center of curvature, will get reflected back in the same medium, right. So, this is how we can do it, and a ray whenever it strikes parallel to the principal axis, it will pass through the focus. Now, how to understand from where the reflected ray will pass? Let it be anywhere it is striking the mirror, that is the spherical mirror. First you can do is you can draw the normal, and we know according to laws of reflection, the angle of incidence is equal to the angle of reflection. With the help of this one, we can find out at which side or in which way the reflected ray will go. The first case, let us see in image formation, when the object is at infinity, object is kept at very far distances. In the case of concave mirror we are studying, the ray diagram will be, the ray will strike parallel to the principal axis, okay, and it will come through the focus, means all the rays coming from infinity get reflected back and comes to focus. So, what will be the position of the image? Where is your image? Image will be formed at focus, right. And what will be the nature and size of the image? Nature is real and inverted, okay, and size will be highly diminished, a very small image is formed. Now, in the second case, let us see when the object MN is kept beyond C, right, it is kept beyond C. So, let us make the ray diagram, this one going to be interesting. So, whenever a parallel ray strikes the mirror, it will pass through the focus, one ray gone. Now, in the second ray where intersection is required, let us take the ray passes through the center of curvature. If the ray passes through the center of curvature, it will come back, the reflected ray come back through center of curvature only. Now, you have to see on which point these two rays are intersecting. So, if you see these two rays are intersecting between center of curvature and focus. So, that is where the image will form. If the intersection is below the principal axis, remember if this intersection is below the principal axis in case of concave mirror, then your image form will be real and inverted. So, the nature of the image will be real and inverted, and the size means you have to compare with the object, it is what, diminished as compared to the object size. Now, when the object is kept at C, the first AB, the ray will strike the mirror parallel to the principal axis, come through the focus. And what about another ray which is going through focus, the incident ray is going through focus and striking the mirror. Then if you make the normal to center of curvature, the reflected ray has to reflect parallel to the principal axis. So, your final image will form at center of curvature only, those intersecting point will be at center of curvature. So, in case whenever there is an object which is at center of curvature, image will also be at center of curvature, nature real and inverted, size same as that of the object. Now, here you can get one concept, as I was telling you that whenever the ray strikes normally, incident ray is normal, the reflected ray also goes in that medium only, right. So, that is why in whenever the object is kept at center of curvature normal, the image formed will also be the same, okay. The distance will also be same, height will also be same. So, there will be in case of plane mirror, there will be 0 reflection and refraction, but in case of spherical mirror, the size of the image and size of the object remains same. Now, what will happen if the object is kept in between center of curvature and focus? Now, in between that, if you keep the object, the ray will strike the mirror parallel to the principal axis and come through the focus, right or not? Okay. Now, another way, the ray can strike the mirror and come back through the center of curvature only, because this is the normal portion of the mirror, right. So, when two rays intersect, it was found that the image was formed beyond center of curvature, right. So, the nature is real and inverted and image is beyond center of curvature, and the size of the image is larger compared to that of the object. Now, when the object is kept at focus of the concave mirror, the ray will strike the mirror, the parallel ray. Parallel ray means parallel with respect to principal axis. The reflected ray will come through the focus and take another ray which is striking the mirror and coming through center of curvature only. You can take any portion of the mirror. So, these are the convenient way which we can draw the ray diagrams. Okay. These 3 or 4 rays we have to take. Now, these 2 rays are moving parallel to each other, if you see, right. Will they intersect? They are not going to intersect, right. So, they might intersect very far, they might intersect at infinity, because nearby if you look at them, they are not going to intersect, they are moving parallel to each other. Okay. So, the final image will form at infinity. The nature of the image will be real and inverted, as the image will be formed just below the principal axis, and last but not the least, the size of the image will be highly magnified. Imagine where they will intersect, very far, right. So, if you take the distance from the principal axis, the image gonna be very, very large, right. Now, let us move to the next part, where object is kept between focus and pole of the mirror. Now, what will be the image? The ray will strike the mirror, the parallel, whenever I am saying parallel means it is parallel to the principal axis. It will pass through the focus, number 1. Number 2, again I will take the same one, the ray striking the mirror and coming through the center of curvature only. But these 2 rays get reflected back in such a way that they are moving away from each other, which in short they are not going to meet at that point. So, what we will do? We will take the apparent intersection, we will extend the ray in such a way that they intersect behind the mirror, right. So, what will happen? A virtual image is formed which is above the principal axis, right. So, you have seen, as I told you, whenever the ray are not intersecting, we have to do what? Apparent intersection, which is in the case of virtual image. So, finally, you are getting, in this case, the image formed is behind the mirror, nature virtual and erect, and size magnified. So, these are the image formation by a concave mirror, which is very important. You see one by one and practice it with pencil and ruler, which will help you. Now, why don't you do an experiment by yourself, okay, to study the formation of image formed by a concave mirror. Yes, you can do it. So let us do in this way. You take a concave mirror, you place it somewhere, and you take a cardboard, stand, pencil, ruler, and a burning candle, that is the lighted candle. So place the concave mirror of known focal length near on the stand. You have to take one stand as well. Now you light the candle and put the cardboard in between. So at different position, okay, suppose at the focal length of the mirror is 5 centimeter, let us just example say. So its center of curvature will be how much? 10 centimeter. Why don't you keep the candle on center of curvature and try to see whether the image is formed at center of curvature or not. Okay, you use the cardboard to see the image. Okay. Therefore, for different position you try to find out the object. You will see that the image form is real and inverted. The flame part will be seen on the cardboard real and inverted as shown on the screen. You keep on moving for different position and find the final image formation. So this is how you can experiment by yourself, which you have studied image formation by a concave mirror. Now let us see uses of concave mirror. It is used by dentists, doctors to get magnified images of teeth, ears, etc. Okay. It is used in torch so that the ray converges. It is a converging mirror. Okay. Also, it is used in car headlight to get the strong beam of light. So this is all about image formation by a concave mirror. See each and every part, it will be helpful for you. Practice, you need to practice this one. You cannot just see and remember. You sit with pencil and paper and ruler and draw the image formation, which will help you. Anything measured against the incident ray are taken as negative. Means the incident ray is coming in this direction and you are measuring in the opposite direction.